Hi everyone, I'm Daikasiwa from Entity Communications or Entity Comm. So Entity Communications is one of the early adapter of SDN, just starting from adopting open flow technologies. And we have had a good collaboration, good relationship with ONF for long years. So I'm really happy to be here to explain about our background, motivation, and vision, and current active project, and potential future project aligned with the open source or white box type context and aligned with the ONF activities. In this presentation, I will explain about our background, motivation, and the overall architecture from me. And after my presentation, when you will explain about the actual practical hot topics inside entity communications. And after our presentation, Andrea will explain about the ODTN project progress. So, okay. And before we jump into the main topic, let me briefly explain about the overall structure of entity groups. This is a little complicated. So there are many subsidiary companies in entity groups under the umbrella of entity holding companies. We are from Entity Comm. It's responsible for ISP services, cloud services, VPN services for enterprise customers. And there are Entity East and Entity West companies is responsible for regional enterprise customers. And Entity Docomo is responsible for mobile region, including 5G. And Entity Data is the company for a system integrator for big enterprise customers. So we have had a good relationship with ONF for long days. So Entity Comm has joined the ONF for more than 7 years, and deploying open flow technologies into our production networks, and then moved to the joining the Packet Optical project. And 3 or 2 years ago, Entity East and Entity Lab joined the ONF activities, starting working with at OnLab in the context of our code. And currently, there are several active projects that we, entity groups, are currently actively contributing to the ONF activities. Okay, let's move on back to the main topic. Let me start with the brief history of the SCN-ization in Entity Comm. We have just started the deploying open flow technology into our data centers to provide cloud services into our customers. So with that, we could achieve the fully automated end-to-end network settings using open flows and using network controllers and customer portal and so on. Then we expanded the region to the between data centers. With that, we connect our enterprise cloud environment with customers' colocation spaces or on-site spaces using the overlay type SDN technologies. And the next step is the gateway between data centers and wider networks. And now there are so many active projects related with SDN and NFV to expand the SDN or virtualization technologies into our production networks. And we will explain a little bit about the RED project afterwards. So although there are a lot of active projects related with SDN and NFV, but we have set 3 common technical challenge topics among all these active projects. The first challenge is to deploying the adapting disaggregated devices to speed up technical innovation or to optimize the inventory of our own. The second challenge is the adopting open software, especially for open SDN controller, from our view, to enhance the customizability or enhance the faster time to market, enhance the interoperability, and so on. And the last challenge is we'd like to provide several kinds of value-added virtual functions, not only network functions, but also more application layer or security layer functions running on the platform. About the open source usage, this figure shows our expectation for open source maturity level enhancement. As Guru said yesterday's keynote, one of the big challenge for us to deploy open source is how to move on to the production level deployment. So we think it is really important for us. And this figure shows our view on the requirement level for the maturity. So for the POC level, it is not so hard for us, but to the production level, we think we need several requirements of documentations or function maturities. Usability and operability is really important for us. And performance scalability is also important. And availability and so on. We need this good balance of these items to deploy to the production networks for the open source. So these are really tough problem to solve, but we are now struggling to tackle this problem with ONF. Okay, so next I'll explain about our technical vision of softwareization of WAN. This figure shows our customers' network usage shift. So in the past, the left hand, our customers used wide area networks to connect their on-site to their data centers or cloud environment in point-to-point or multi-point manner. That's really simple. But in recent days, the right side, most of our customers are using cloud services, including EARs, SaaS, PaaS, or more application layer, security, IoT, big data analysis, and so on. That functions are running on the cloud environment that are accessible through the wide area networks. So with that, most of our customers are wanting for wide area networks to connect, like just plug in from their on-site environment, and our wide area networks can connect to the cloud services in easy and flexible manner. So to realize that, we believe that we should provide flexible and dynamic wide area networks combined with value-added virtual functions. Virtual functions not only network functions, but also security variety or something like more value-added functions. We are calling VXF. So to handle this situation, we are developing some platform inside NTT. The first one is the VXF platform. That is a common and integrated platform that can onboard various virtual functions in integrated manner, and that are deployed to our data centers or EARs environment and network edge and customer premises environment, something like a universal CPE and so on. And to connect this platform, we are now designing the next generation wide area networks. This figure shows the one row shift to realize the concept. We think that our next generation platform should provide the right hand of the features, like including fine-grained application-centric slicing and traffic engineering, or L2 or L3 pipe plus service function chaining functions, and dynamic control by SDN controllers, or by combined with the AI type automation or big data analysis type configuration or something. This figure shows the overall requirement to realize the next generation wide area networks. That includes traffic management, network slicing, scalability, simplicity is really important, and flexible traffic isolation. For that, we think that there are two levels of isolation. There should be two levels of isolation that is provided by transport network layer and the service network layer. And the openness is really important for us to improve interoperability among the virtual functions or something. Okay, so that's the last slide from my part. The explaining about the overall architecture of the next generation WAN. There are three components. The first one is the bottom layer transport networks. We believe that the next generation transport networks should be simple and fast, using multi-vendor environment and using white box-like, disaggregation-like devices as much as possible. And above that, there is the intelligent service networks that should provide slicing or service function chaining or traffic control to our enterprise customers. To manage them dynamically, there is a flexible controller or orchestrator to manage these devices with open interfaces like netconf, opcom, config, PCE, or something. That's a general view. And to realize this kind of challenges, again, we have a good relationship with ONF. And after my presentation, when you will explain about the hot topic of the ODTN, towards the journey to the ODTN. And also, I'd like to, one more thing to say, the Entity Lab is demonstrating the contributing to CBA project that is demonstrated in the exhibition room booth. So if you have time, please look at. So that's all for my part. And let me introduce Wenyu Shen. He's the leader of this technology development in the region of SDN and FB. And he's also a TUT member of ONF. So please come in.
Hello, my name is Wenyu from Entity Communication. Today it's really my honor to stand here to share with you our latest activities on the multi-layer network slicing and transport SDN. So before I jumped into the discussion on ODTN project, I would like to give you some backgrounds about the whole story. So why we joined ODTN and why we contribute and put efforts on this area. So this is the overview of the activities is inside Entity Communication. We call it dynamic multi-layer network slicing. So there's several parts actually behind. The first one is the slicing here. Nowadays there are more and more applications appear, while different application might require different requirement on the isolation itself. For example, some application need dedicated optical path, while others not. They can share with other applications to be aggregated into some tunnels, overlay tunnels in the network. So this is one point behind. The other one important point here is the traffic engineering. So now we receive more and more requirement on how to handling traffic dynamically inside the network, like especially in the context of 5G. So different applications might have different requirements, like bandwidth, like jitter, and like latency, for example. So we think that a mechanism behind to dynamically control the network, to assign the resources on demand according to the individual needs of the application. So this is what I mean by traffic engineering. So when I mention dynamic, so we have to gather, collect dynamic information from the network, like telemetry traffic, logging data from the network. So this is the data analysis that I want to explain here. So we retrieve data from the network, visualize it, and do analysis based on kind of machine learning technology, and finally make a decision and to change it to the configuration, and finally to configure the whole network. Last but not least is how could we create such network in a low cost? So this comes to the needs of disaggregation. So I would like to introduce disaggregation later a little bit. So the idea behind is to not use a big vendor box, but instead we aggregated boxes into several components. So I will give you detailed introduction later. So before we continue, I would like to share with you some live use cases about this activity, about how we use slicing behind. The first of all is the intranet SaaS access for enterprise customer. As shown in this picture, we have just assumed that we have two applications. One is the intranet data accesses. So just assume that this enterprise, they want to access their databases in their data center, for example. Well, there's another use cases, which is other application for SaaS access. But however, these two different use cases may require different bandwidth and also may require different latency, like here. For these use cases, we might create different tunnel on the service layer and assign different QoS policies and do the different traffic engineering for these two applications. However, when we see a different use case here, like storage as a service, so some users, they will use SaaS access while they will keep the storage outside of the SaaS database. They can use third-party storage, or they can use our storage services that are located in different data centers. So when we talk about the access to the storage, sometimes it requires ultra low latency slice and a huge bandwidth. So in this case, we might create not a shared tunnel inside the IP network. We might create a dedicated optical path directly for such usage. Then we come to a very hot topic these days about 5G. So I think, in my opinion, 5G is not about wireless. Many people are talking about 5G in the wireless context. But however, I think one important topic here is the mapping between the mobile, the wireless domain, and the fixed domain. So when the traffic comes from the mobile domain, there should be some way to map into the fixed domain and get the guaranteed network resources, enough resources to meet the requirements of the individual service. And also, in the DICE presentation, we are developing kind of edge cloud. So sometimes, according to different needs, we might migrate application from the centralized cloud to the edge cloud. But in correspondence to such behavior, our network should behave dynamically accordingly. So we have to change the network in order to adapt to the changes of the VNFs. So this picture shows a field and trial activities is inside our company. So in this POC, we have 4 data centers that deployed in the area of Tokyo. And data center, some is for the edge cloud, but some is we assume that it is the centralized data center. And you can see this multiple layer network that connecting this data center. The first of all is the optical layer. The transport SDN setting here. We use the kind of white box switches, and also we use disaggregated devices. I will discuss it later in detail. And above that optical layer, we create a IP layer. So we use a segmenting routing, in order to handle the traffic, in order to handle traffic engineering on the IP layer. Also, we assume some typical use cases and typical application like web access, DB access, and storage access. So according to different applications, we will, for example, we were, to assign a dedicated optical path for storage access, while to keep, database access on the segment routing layer. And finally, for example, we can keep the web access on the even higher layer, like IPsec tunnels, and shared by many of the users, because it's a best effort service. So in my presentation, I speak a lot about multi-layer, multi-domain, and multi-vendor. So I think that's the key requirements behind. So we have to, the technology should support these kind of requirements. And also, I talked a lot about dynamic. We need a dynamic resource, dynamic bandwidth, and routing in order to meet the different requirements for different applications. But the final goal here is to shorten the lead time for the system provisioning and to optimize the network quality, and finally to simplify the operation. So here comes to the system architecture for the transport SDN. So you can see that what we are seeking for is a kind of common platform that in the middle of the whole system. And it provides a kind of abstraction for the underlay devices. Just like I said, the device environment can be very dynamic. It can be compressed by different vendor, by different layer, and different technology. So a kind of abstraction is really needed. And also above that, we are seeking for more in-house development, to create more value-added services behind. So when we talk about abstractions, so as I mentioned, the network can be multi-layer and can cross multiple domains and can be made by multiple vendors. So a kind of abstractions is really necessary to hide all the details behind and provide a unified way to the upper layer applications. And also, when we talk about in-house, from my point of view, open source, when we talk about open source investment, we are thinking about we're expecting that some common platform will appear, which can be shared by many different operators, so that we can reuse such platform in order to reduce cost. But many people might ask how to compete with your competitors. So I think that's the point here. So now we invest a lot of resources, our developer resources inside. So we will utilize the common platform and develop our own applications is above the platform, so in order to make a differentiator in the competition of other operators. So here, as long as we have the platform, I think there's a two point that we can develop the application by ourselves. The first one is the service application. It can be made by entity itself, and also it can be made by third-party vendor, and also it can be made by platform vendor. And also on the device level, in a similar way, as long as we have the common platform and open and standardized APIs, we can ask the device vendor, to provide such device driver for us, and also we can develop our own. So let's look at the picture in a bigger view. So this shows the position of the SDN controller, what is the position is. So as also in Dai's presentation he mentioned, so actually we have we were providing end-to-end solution to the customer. So from access network to the edge cloud, and finally into the cloud. So our network is, it's actually across multiple domains. So in our design, we create, different controller for different domain, while above it, we have our in-house orchestration framework. So we develop our own orchestration facilities in order to coordinate different controllers in different domains. So that's the big picture of our network. So Dai has already covered this slide. So the main technical challenges is here is 2 points. It's the disaggregated device and open SDN controller. And for sure, the value-added VNF. So today I will cover the first 2 points. So I talked a little about disaggregation in the beginning of the presentation. In the optical layer, for example, so far all of the device is made by single vendor, and the device is vertically integrated, so as a whole. So single vendor, and also for the northbound interface, it is also vendor-specific interface. So in a result, the controller for such device is also should be made by the single vendor. However, what we are seeking for here is that to disaggregate the device, to make it more componentized. So in this way, more and more participants can join to create device. So in the future, we might not use a big device from single vendor. We can use device that can be assembled by different vendor. And also on the management point of view, we are seeking for open and standard API. So in this way, the controller can be made by open source and also can be made by third party. So what is the current situation in different standardization body? As shown here, so different bodies have their different focus. Like, some standardization body, they develop open device, while somebody they are developing standard APIs, and just like ONF, so we develop ONOs. So we think that we should have a kind of a reference implementation or reference design that combine or reuse all of the great outputs from different standardization body, so that we can create an end-to-end solution to the end customer. So the expectation for ODTM project here, I think is 2 points. First of all is to make ONOs production ready. We're expecting ONOs to support more interface, like OpenConfig, TAPI, and netconf YARN support. And also on the other side, so what we are expecting for ODTN is to create the kind of ecosystem on the device level. I think by utilizing the common platform, I think device development will also be activated. So that's another point that we are expecting, from this project. So here comes to the brief introduction about the ODTN project. You can see that 5 big operators is now contributing to this project, with 12 vendors here and supporting the deployment and activities for the operators. So this is the schedule behind. So I don't want to spend more time on it. And you can see here, this year we launched the ODTN project, and we have a very clear mission goal, like 1.0, 1.5, and 2.0. And also in parallel, we have the plan to the field trial and production development in the future. So that's all for my presentation. Now I would like to give my mic to Andrea. He is the ODTN leader and did a very good job in the ODTN project. I think he's better to give you some great insight behind the project, what is actually we are doing in ODTN.
I'll let you know what an implementation of ODTN is. So start with what is ODTN. It's the Optical Disaggregated Transport Network. It's our 4th reference design. You've seen SIBA, you've seen Trellis, you've seen UPAN. This is the 4th one that we launched. And so through the slides of NTT, it was really clear that there is industry traction between NTT and Telefonica and other operators for this transport network disaggregation, driven by open and common data models for both devices on the southbound and services on the northbound. And this traction can really lead the disaggregation of optical networks. The scope of the project is also to bring the ecosystem together through a reference implementation, including both northbound APIs, a controller, southbound APIs, and devices, with clear lab and field trials towards deployment in a phased approach. We're not going to tackle all the problems at launch because that's not possible. So we're going to take it a little step at a time. So where does it fit? It fits really in the middle. We leverage open compute projects, data center peripherals. We leverage TIP peripherals, for example, Cassini, to which we have a demo at the booth. We sit as the transport and enable end-to-end orchestration towards this platform through ONF, through OSM, or through any OSS, BSS. Really, what we do is that we are targeting the optical transport space with the first open source project going full stack, from the northbound APIs of the controller to the southbound API of the devices. And the idea is that we have an ecosystem to deliver robust solutions, white box devices, and enable an end-to-end provisioning of the transport network. So we said, let's start from one component. The first component that we wanted to target are the transponders. Why the transponders? Because in the optical domain, the transponders are the faster changing devices. So the modulation, the tuning of the wavelength, the tuning of the power, the capabilities on the transponder side is where the change happen, while on the open line system or other ROADM components can have a longer lifespan. So we decided to tackle first, in phase 1, the transponder disaggregation in order to realize also a DevOps model through SDN and build a continuous integration, continuous deployment pipeline between the operators, the vendors, and in general, an open source software stack. So at the moment, we're working towards this solution. We already done the transponder disaggregation, so ONOS is now capable of talking through OpenConfig to the transponders. And you may have heard OpenConfig in other contexts, for example, with the Stratum project or UPAN. And that was really using some of the OpenConfig models, but the OpenConfig group really also have optical targeting the optical space set of models, and that's what we are using here. So we're using a standard interface, which is open source, for the transponders. The transponders in our deployment are bookended, so you will have, for example, a Cassini box talking to another Cassini box across the OLS. You will have a Nokia box talking across the OLS to another Nokia box. We're targeting this deployment with an open line system, which is abstracted to us to ONOS through transport API from ONF, and it is exposed as a big switch single device with NNI ports on both ends connecting the transponders, at least for this phase. And then ONOS is really receiving requests from an OSS BSS through the transport API, which we found very good to target an end-to-end connectivity request for the optical domain. So we, as I said, we have done partially phase 1.0 with transponders, point-to-point, with the OLS controlled out of band. This is already in trials, and I will speak about that in a moment. Obviously, the code is still proof of concept quality, and we are keeping and improving it through iterations. It's open source, so I welcome you to join and contribute to it if you want to make it better. What we're working towards right now is use, as I said, the open line system, still point-to-point, controlling both the transponders through OpenConfig and the open line system through TAPI. And this is an ongoing effort. Both NTT, as my previous speakers pointed out, and Telefonica are leading this effort, and the implementation is in progress, both through the driver subsystem in the ONOS core and the northbound APIs. At the same time, we're also working towards a phase 2.0, which is including ROADMs instead of the open line system. This is a less towards trial for now, because still the API is in progress. The definition of that is still open for debate. There is some concern about what do we use, open ROADM, do we use TAPI towards the ROADMs? So that's up for debate, and I encourage you to join this debate too. And that is really led by Telecom Italia and a European research project which is called Metro Hall. So let's see what we did in terms of trials. So it's all good, we have some software, but we really need to put it in the lab, because at that point, the lab really tells you what the production requirements are and what you're doing good, what needs to be addressed, and what needs to be done better. So with Telefonica, we have a lab trial through Nokia, and we're targeting an open line system from ADVA. Through NTT Communications, on the transponder side, we used the Infinera devices, and also at the moment, we are putting in the lab EdgeCore Cassini box with IP Infusion software on top of it. The open line system in respect for NTT Telecommunication is still up for debate. Obviously, ADVA is one option. Infinera is another option. We might have, I'm in talks with, for example, like also Juniper and Nokia to have that component over there. But what I really want to stress out is that every piece in here exposes open API. So the transponders expose OpenConfig to ONOS. All of the Nokia, Infinera, EdgeCore, and also others such as NEC that we have worked with, they expose OpenConfig. We define a standard to control the transponders. This is a key piece from the presentation before me. And also the open line system that work with us, we make a requirement for them to speak TAPI, Transport API from the ONF, which you can hear more about this afternoon in the optical track. And that's a TAPI version 2.1, because we need those optical parameters that the photonic media encompasses. And so we require on the southbound these two specific APIs, OpenConfig for the transponders and the Transport API for the OLS. So the timeline, when you talked a bit about it, at the moment we're targeting for phase 1.0 with the OLS integration, a first demonstration of it in March 2019 at OFC, so a full end-to-end point-to-point control of both the transponders and the OLS. We have shown, and we are currently showing, a phase 1.0 transponder a demo at our booth with Cassini, and we have previously shown it with Nokia devices, NEC devices, and Infinera devices in different lab trials that I've talked about. So let me just also place ourselves in respect to other open source initiatives. What you heard before and in these keynotes and all around this conference is that we do not need to work in isolation. We need to work with other bodies, we need to work with other people, and we need to reach consensus. So ODTN is really using the ONF Transport API, which is a widely adopted support, and it has growing acceptance, especially around the optical domain. And it's using it both for service provisioning, topology, but also on the southbound to reprovision the service from ONOS to the open line system. We're using OpenConfig, well-known open API, and we're using it for transponders, and in the future, maybe also maxponders, WSS, amplifiers, and other devices. Obviously, we're also looking at Open ROADM, since it's a big initiative for the ROADM devices. And all of this is really done to achieve the goal of being the first open optical open source project. I also want to spend a little bit of time talking about another initiative that was launched at the TIP Summit 2018, and which we are looking to collaborate stronger with. Always at the goal of not repeating any work, but really reaching more industry consensus. So at TIP Summit, NTT and Telefonica, which are behind the ODTN project, launched Candy, which is an architecture for network disaggregation, which encompasses both the network edge, the optical backbone network, and the VNF data center platform. So when this was launched, and previous to the launch, I was involved in the discussions, and I really looked at it and said, oh, look, the backbone network, this is what ODTN is targeting. So let's get together and make sure we agree and we have the same goal and we work together towards this, this use case. So what are the benefits that we're looking at achieving? Really, having standard and open APIs between TIP and ODTN and ONF. We don't want any duplicated effort. This is key. We want to share the knowledge, share the resources, share the findings, and also achieve a stronger industry consensus, and thus a stronger impact towards across the optical domain. Having common test labs where people can try things out, can try ODTN, can try different type of devices, can try different type of APIs. And also, through our collaboration, accelerate the trials and accelerate production deployments, which is key for that transformation that is needed also in the optical space. So what do I want for you to take away from this presentation? That ODTN is the first and only open source software stack for optical networks. There's really some proprietary stuff out there. But as fully open source, we're all the only one in the space. So please come and join and collaborate. And we accept fully not open source components. Like IP Infusion brought in their Oknos platform, which is not open source. But at least from a controller and API perspective, we're fully open source. We have standard and open APIs. We work with a variety of vendors, and I encourage, if like any other vendors that was not mentioned in this presentation, to come and talk with me at the booth, and so we can collaborate together. We have an incremental approach. First the transponders, then the OLS, then figure out the APIs for phase 2.0 and the remaining disaggregation. We go to lab trials through a feedback loop. We have a path to production, and we collaborate with other open source initiatives. As a last slide, and then we can go to lunch, is that I want to really thank the great community that is behind this project, mainly NTT Telecommunications and Telefonica, for their great contribution, both in the example platform and the RD design, and also many vendors, Nokia, Infinera, Adva EdgeCore, and a lot of others that are really collaborating with us on this project and putting in resources to make this a success. So I encourage you to join us at the ODTN session this afternoon at 2 p.m. Salon 3. Come and take a look at the ODTN demo at the demo booth. And if you have any questions, ONF is such a small organization that it's really easy to get an email. It's andrea@opennetworking.org. And with that, I thank you for listening to me.